Welcome to LPKF here at SMT Connect. I'm joined by Patrick Stockbrugger, who is the product manager for the laser cutting machines. So welcome, Patrick. Yeah, you've got a brand new system out at the show here this week, which is the Cutting Master, the one behind us. Tell us why it's what the benefits are of using laser cutting versus regular routing of a PCB.
So we have quite a few technical advantages also compared to traditional depanelling methods like milling or sawing. So the systems we have are very accurate. So we are talking about an accuracy of roughly 20 to 25 micrometer, plus minus. We also are not generating so much dust compared to traditional milling systems. So the particles which we're generating are very small, and it makes it easy also to exhaust them. So the process is very, very clean. And of course, especially for thin materials, the laser process is very, very fast. So we can also achieve very high cutting speeds, and that of course makes the laser very attractive. Also that you are very flexible regarding the design. You can cut like right next to components. You can also cut any shape of geometry, so it makes the user in the end very flexible.
Right. So basically, where we're moving towards more miniaturization and this type of thing, you're able to cut much finer lines closer to the board, less potential debris for contamination or anything like that, and you can do it faster. What about? I mean, obviously, you do this in a series of micropulses. So what about what's the potential for burning a laminate? Let's put it that way. I mean, is there certain thicknesses you can go to? How does this work?
Yeah, so regarding the thicknesses, we can cut up to 2 millimeters quite fast. So we can also cut substrates which are thicker, but to admit at that point we're still a bit slower than milling processes. But when you are staying below 2 millimeter, 1.6 is standardly used. We are as fast as a milling system, and for even thinner materials we're even faster. So it's not linear between like reducing the material thickness and cutting speed. So if we reduce it, it gets twice or threefolds faster. So it's very helpful also for thinner materials. And regarding the utilization also of the materials, so the cutting channels are very thin. So we can, for the fast cut, for example, we can have cutting channels just 100 or even 50 micrometer wide. So very, very thin, and thereby we can also get more PCBs on one panel. So we are very flexible regarding the design, and also carbonization. There is some kind of topic of the past because we have like very short pulse laser. We have nanosecond and picosecond lasers integrated. We also have tensor technology, which helps us to guide the laser beam even faster, and also thereby, we do not heat up the material too much, and thereby we also achieve a better quality and do not have that kind of carbonization which you might have had in the past with laser systems.
So where would be the cutoff typically between using the nanosecond laser and the picosecond? Maybe 1.6 millimeter or something like that?
So it also depends on the application. So mainly for FR4 applications, it's totally fine to use a nanosecond green laser system, for example, and also for most foils and flexible PCBs, a UV nanosecond laser is totally fine. But when the substrates get more sensitive, you should go to a picosecond laser, and also if you want to achieve a better cutting quality. So when you want to have a better quality in the same time, you should go for a picosecond laser, and then you can also achieve this goal.
Right, okay. And so when it comes down to the speed that you can get, typically using a laser might be equally as efficient as using a standard, two standard routers, for example.
So for this system which we are presenting here, we also present the fast cut, and for fast cut we can get, for this layout, cutting speeds of roughly 10 millimeters per second.
Okay.
So it's already very fast, and also for a clean cut we are in a range of 5 to 6 millimeters per second. So already very fast. So there was a lot progress in the last years. Cutting or effective cutting speed is increasing constantly, so there's still a lot of movement, and we're still getting more and more efficient processes with the lasers.
What about the different routing thicknesses? Can you do different widths of routing thickness?
So usually we're putting multiple cutting lines of the laser next to each other. So the diameter of one cutting line is roughly 20 micrometers. So the focused laser beam just has roughly 20 micrometers. But when we are putting like multiple lines next to each other, we are thereby generating a wider channel.
Yeah, I see. Okay, great. So, brand new machine. Is it ready to go into the field now, or is it still in beta testing stage, or where are we?
So this system with sensor technology will be available end of the year. So end of the year we will deliver the first systems. We already have some systems with nanosecond lasers and tensor technology already available, but picosecond lasers will be available end of the year.
Excellent. Okay, great. Well, thank you very much for that.
You're welcome.
Productronica coming up at the end of the year. Anything else coming out in time for that?
Yeah, for sure. We will also present some brand new also automation systems which we offer at the show. Also, we might present a new laser system. So there's still something coming up on the next trade shows.
Okay.
So,
well, we'll look out for that. Well, thank you, Patrick, for giving us a walkthrough just now. Okay.
You're welcome.
Thank you.